solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Greasy Caleb, and today we're going to be taking a look at a fairly older module, Placeholder Talk. So this is the way the module looks. It's got a bright yellow background, and it's got 4 numbers at the bottom that are going up and down. Note that that's just part of the module design. Rather quite cool design, I will say. And we have a large display here that is going to be having 2 different phrases in it. The first one is always going to be containing the answer. However, there's going to be a bit of a different results of how it's designed here. And then there's going to be a second phrase, which we will get to in just a second. So what's going to be happening is that we're going to be trying to calculate 2 different values for each of the 2 different phrases that we get here. And that's going to be done through these calculations, which I will get to momentarily. Both phrases have their own numbers, and we need to figure out both values and add them together. And if it happens to get outside the values of 1 through 4, we're going to subtract or add 4 until you are in that range. Then this new number is the button label which needs to be pressed, and just like that, the module will solve. And if not, if you happen to press the wrong one, it will regenerate a new sequence. Or a new phrase rather. So what we're going to be doing is we're going to be extracting the value from the module's first phrase. So as I said, what's going to be happening is that there's always going to be the prompt, the answer. However, the results that might be after the answer are going to be completely different from each other. So as you can see, the answer and the answer, they're all the exact same. However, they are not alike at all. So what's going to be happening is that we're going to start with n equals 1. So n is actually going to be equal to 1. So we're going to be starting with the value of 1, not 0. Keep that in mind. Then what we're going to do is we're going to add 1 to n for every current strike, and then we're going to use the 3 tables below. So we don't have any strikes currently present, so I'm teaching you guys not to strike. Keep that in mind. And then what's going to happen is that we're going to essentially take a look at these 2 cases here. So we're going to subtract one of the rows in the left or middle tables from n. Note that it's going to be exactly 1 because it's the words after the answer. Specifically is going to be the is right here. So is going to be value of 1. So we're going to be subtracting 1 from n in this case, which is going to be 1 minus 1 is going to be 0. So it's always going to be in exactly one of these prompts. Keep in mind that if, for example, we have and is in, there is also the possibility of them just being combined. So to keep that in mind, it's going to be exactly one of these tables here. And then on the right side here, on the right table, there's always still going to be exactly 1. So in this case, the answer is billionth pos. So in the case, billionth pos wants me to add. This is going to be specifically me adding one of the rows to the right side. And now remember, if it happens to be a subtracting negative, it's going to be simply adding. If it's going to be adding negative, it's going to be subtracting, yada yada. You know how that works. So in this case, we're going to be adding 10 to n, which in this case will give me a result of 10. So this is going to be the result of our first phrase. And if none of the phrases fit in either table, refer to the row that contains nothing. There is 2 possibilities of where there's literally nothing in them. This case will be used if you happen to have a phrase that doesn't make sense or just doesn't fit in there. So to keep that in mind. And then we're going to apply both tables. N will be calculated for this will be the first phrase. So we already have 10 for our first phrase. Now, let's move on to the second phrase here. The second phrase is probably a little bit of the more complicated one, but it's also very easy at the same time. So what we need to do is we need to take a look at the following message in the second place here. This is going to be a rather quite large table lookup, for example. However, there are going to be a couple of rules that we need to pay attention to. So we're going to find the exact message below, and the number given is the second phrase's value. However, there are 2 exceptions that must be followed. And these 2 exceptions are, if the phrase contains an odd number of forward slashes, we're going to add 1 to the second phrase's value for every backslash present on the module's display. So an example of this could be, for example, this display right here. This has an odd number of the forward slash, which in this case it has 1. And then what's going to happen is that we're going to add 1 for the second phrase's value for every backslash present on the module, which in this case, it would start off with a value of 2. And then we would add a 2 for every backslash that we have present in this display, right here. And just like that, it will be a value of 4 instead of 2. So that's one of those cases where it applies. But remember that it only applies for forward slashes being an odd number, and then you add the amount of backslashes. So there could be cases where you just don't have we don't have any backslashes at all. For example, right here, you don't have any forward slashes, which means you're not going to be adding any of the backslashes here, and vice versa. That could possibly work as well. So that's one thing to keep in mind. And then finally, the second one is a bit of a rarer case because of the fact that it doesn't happen that often. If the phrase asks you to add or subtract n, apply it to the second phrase's value. So what's going to be happening is that it only appears in a couple of examples. The best ones that I can give you are right down here. Add minus n in the second phrase where, or add negative n in the second phrase where n is the amount of times this module has been solved in your current BOM. This is going to be specifically referring to the case of multiple this is going to be referring to multiple modules. In this case, we actually didn't get any of those examples. But what happened would be is if I happen to solve one of these three on here, what would happen is we're going to add negative n in the second phrase, and this value is worth a 3, where n is the amount of times this module has been solved in your current BOM. So it would be a 3. Then we would add negative 1, which would be a 2. And that would be what you would get right there. That's how that works. And then it's the same thing for this one over here, except you're just adding n. With the amount of times this module has been solved in your current BOM. So it's a positive or a negative n. Make sure you pay attention to that terminology right there. But I believe that those are the only 2 examples I've seen in all of these tables here, at least as far as I've seen. But yeah, it looks like that's it. And just to make sure, you have to make sure that you read it a little bit carefully. But if the phrase asks you to add or subtract n, apply it to the second phrase's value. So it'll have you add or subtract n, and n will be applied to this value that you got from here. Make sure you pay attention to the value of the table that you're in. So let's get into this part here. So now the second phrase is says some Chinese characters. Now, what's important to note is that it has to be exactly what it says on the module. Now, if there happens to be, in this case, some Chinese characters, which there can be right here, for example, that is not correct. This is not the correct one that we're looking at here. If we search up some Chinese characters, this is the correct one that we're looking at right here. So just keep in mind that it is exactly as the message says it is, like any normal crazy talk, and we're going to get a value of 1 from this, because none of these other exceptions apply in this case. So what's going to happen now is that we've gotten both of our phrases values here, and what's going to happen is we're going to add these guys together. 1 plus 10 is going to be an 11. So in this case, we're going to now subtract 4 until we get into the range of 1 through 4, which is going to be equal to a 3. So now 3 is where we're going to press on the module to solve it. And that has one of the smoothest solve animations. I love it. So let's take a look at another example. So that module is pretty straightforward. It really is not much to it. It's looking up values. However, just be careful with some of these rules. It can be a little bit easy to trip up. The starting with n equals 1, it can be a little bit weird. Normally, we're all used to starting with 0. I know that from experience, don't you worry. But make sure that you have to pay attention that it's going to be exactly one of the rows for each the left and right, left and middle, and then the right by itself. It's going to be exactly 1 and no more. So now let's take a look at this one. The answer, in this case is going to be right here. And then third plus is going to be right here. So now what we're going to do is we're going to start with 1, remember. And then we're going to subtract from n. We're going to subtract 1 from n, which is going to give me a 0. And now we're going to add, on the right side of this table here, we're going to add 3 to n, which is going to give me a 3. And that's going to be our first value taken care of right there. So now, the second phrase is going to be, oh, we blew up. Oh, we blew up as in the color. No, we didn't. Not the color. Nope. It's going to be just the normal B-L-E-U. B-E-W, excuse me. I literally, oh my god. Okay. Oh, we blew up. In this case, this is going to represent a value of 4. So now this is going to be our second value right here. And what's going to happen is that we're going to add these guys together, or we can simply just get rid of this 4 because we're simply going to be moduloing 4 until we get into the range. So in this case, our final answer is going to be 3. And just like that is a solved module. Let's take a look at our final example here. So the answer is in the. Now, this is where things can get a little bit easy to mess up. So for example, we have is, or is the in, for example, is in, and there might be a the, for example. So just keep in mind that it is referring to the is in the position, which currently represents is in the, which currently represents 0. It will be exactly 1 row, and there's going to be a lot of duplicates that might mess with you. Just keep in mind that it has to be exactly 1. So now we're going to start with 1 like we normally do. And then we're going to subtract n from or we're going to subtract 0 from n, which is not going to change it. Perfect. And then is in the fifth plus. Fifth plus is going to be a 5. And this is what we're going to add to n. 1 plus 5 is going to be a 6, and that's our first phrase figured out. Then next up we have A, B, C, D, E, which in this case is spelled out a little bit funky. So A, Y, Y, which in this case is going to be right here. This is going to be corresponding to a value of 4. Now, if we add these guys together, or we simply can just get rid of the 4, we do not care about the 4 because it's going to be subtracting 4 because of the fact that we're going to be adding 6 plus 4, which is going to be a total of 10. And then we're simply just going to modulo this by 4, which is going to be then a 6, like we had beforehand, and then a 2. So 2 is going to be our final answer. And just like that is a solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.